All right, so today we're going to be looking at limits that don't exist and estimating limits from a table. We've got a warm up here. I would encourage you to try this and then come on back. All right, so before we move on here, just keep in mind that a limit is a number or it does not exist. All right, so topic today, limits that do not exist and estimating limits from tables. So there are three ways that a limit can not exist. The first one is if f of x approaches a different number from the left and the right. And we saw this yesterday in our lesson. So we've got a function here, f of x equals -2 when x is less than 0 and 1 when x is greater than 0. So if we graph the top part of that, it would look just like this. It would be a horizontal line. It would have an open circle right here because of the fact that x is less than 0, and it would continue to the left forever and ever, and then x would jump to 1 when x is greater than or equal to 0. So now I would actually have a point at 0, 1. And it says, what is the limit as x approaches 0 from the negative side? So the negative side is always, as x comes in towards 0, like this, the y value is always -2. So we would say that the limit there is -2. But then I jump to the positive side and I come in towards 0 from the positive side, and all of a sudden my limit is always 1. So therefore, because those two values are different, we're going to say that the limit does not exist. Okay? The next one is if f of x increases or decreases without bound as x approaches a given value. So here's another good example here. The graph of f of x equals 1 over x. If you were to graph this, number one, it has a vertical asymptote at 0. So imagine drawing your vertical asymptote here. And if we were to plug in some values for x, it turns out that we would, if we plug in 1, we would get 1. If we plug in 2, we get a half. If we plug in 3, we get a third. And this graph has a horizontal asymptote at y equals 0 here, but then as it gets closer to 0, it just keeps going up and up and up towards infinity. And if we were to graph the other side, if we were to plug in -1, we would get -1, and then -0.5, -1/3, and so on the left side, the graph is going down like that. Okay, and that's what these limits are asking for. What is the limit as x approaches 0 from the negative side? So as I approach 0 from the negative side, I'm just going down, down, down towards -infinity. Now, -infinity is not a number, so we could also say does not exist. On the AP test, they usually want to know if you know that the graph goes to positive or negative infinity. On a free response, you can say it just does not exist. The same thing's happening on the right side, only this time as I approach 0, the right side just keeps going up and up and up towards positive infinity, or again, we can say does not exist. And if a limit does not exist on either side, then the whole limit does not exist. All right, those two are the two big ones. Do I have a limit that approaches, increases or decreases without bound, or do I have what we call over here, this is actually called a jump discontinuity. Jump discontinuity. So if I was to trace the graph with my pencil, I would have to pick it up and jump to the other part of the graph in order to continue. All right, the last one where a limit does not exist is if f of x oscillates between two fixed values as x approaches a given value. So you'll notice on this graph, the graph of sine of 1 over x, it comes in from the left side and it's going up and down, it's jumping between 1 and -1, it looks like here, and then as it gets closer to 0, it just starts going crazy in there and just literally jumping up and down and up and down and up and down all the way through there. And so we would say in that case that the limit does not exist. All right, so we're going to be using our calculator again here. So If you don't have your calculator, you may want to run and grab that. What we're going to do here is we are going to find the limit. We have this function f of x equals x squared minus 4 over x minus 2, and we want to find the limit as x approaches 2. Now, if I just plug in 2 to the function, you'll notice that the top part, I get 2 squared minus 4, which is going to equal 0. If I plug in 2 on the bottom, I get 2 minus 2, which is also equal to 0. So I would end up with 0 over 0. So there's something going on here. This is actually the situation where we get a hole in the graph, or something else may be going on. But 0 and 0 means we have a hole in the graph. Okay, so we know that we cannot plug in 2, because if we do plug in 2, this is undefined. But what's happening as I approach 2? And so this table below shows the left side of it is as x approaches 2 from the left, and the right side of the table, x is approaching 2 from the right. So you notice I went to 3, then to 2.5, 2.01, and so I'm getting much, much closer to 2 from the right as well as from the left. So I'm going to graph this on my calculator, or I'm going to type it into the Y window, so I've got that in there. And if you recall, we can go to our main screen here, and we can simply pull up the function. So I'm going to hit alpha trace. I'm going to pull up function number 1, and then I want to evaluate that function at the number 1. So I would type 1 in the parentheses, hit enter, and I get 3. And then I want to do the same thing again. Now, I've got an easier way to pull this up. I can simply highlight it, hit enter, and then go back and change the number in here. The next one's going to be 1.5. And I can continue to do that. We'll do it one more time here. All right, so I'm going to hit enter. I'm going to change 1.5 to 1.9 this time. And I can continue to do that, and we would end up with these numbers in our chart. We're going to get 3, 3.5, 3.9, 3.99, 3.999. So you can see that as x approaches 2 from the negative side, it looks like these numbers are getting closer and closer to 4. And then I could do the same thing over on the right side. If you plug in 3, you actually get 5, and then you would get 4.5. You would get 4.01, 4.001, and finally 4.0001. So you can see that we're getting, as x approaches 2 from the positive side, from the right side of 2, these values are also getting closer and closer to 4. These two values are one-sided limits. If the one-sided limits are equal to each other, then we say that the limit, the y value as x approaches 2, is 4. So I would encourage you to practice with your calculator. Here's your next function. We want to find the limit as x approaches -3 of this function, square root of 1 minus x minus 2 over x plus 3. You can already see that if you plug in -3 to the bottom of this function, we're going to have a problem down here. Okay, so I know that -3, just by looking at it, is undefined. So you're going to take out your calculator, you're going to punch in this into y1 again, and then you're going to pull up the values, and we would end up with values of -0.2485, -0.2490, at -3.001, we're going to get -0.24998. If I go to the other side of the table and start at -2.9, we get -0.2516. Then we get -0.2502. Then we get -0.25 0.5001. So you can see that we're not moving a whole lot here, but we are getting closer and closer to what appears to be the value of negative 0.25. So we would say that this limit is negative 0.25. Okay, again, I would suggest turning off and taking a look at this one, not only with a table, but graphically, and then come back and see what you've got. All right, so I've got my values from my chart. So what I did is I went to my calculator again. I went to my Y1 window. I graphed that. I'm actually going to look at the function since we're here. So if you were to graph that function, it looks just like this. It should look familiar. It's exponential growth here. Now, it looks like we have the full graph here, but if you were to actually try and plug in 0 here again, you would find out, and you can go back and look at your graph or your equation, you cannot plug in 0 to the bottom of that equation. You end up with a problem here. If you plug in 0 to the top, you get e to the 0 minus 1, and since e to the 0 is 1, that's 1 minus 1, so you get 0 on top. And obviously, if you plug in 0 on the bottom, you get 0 on the bottom, and we have an issue here. That means that there is a hole. Anytime you get 0 over 0, there's a hole. And so this graph actually comes across just above the x-axis, stops, jumps over, and then keeps going up the other side just like that. All right, that's it.